Hello students, in this lecture I am going to teach squares of the numbers from 25 to 75 based on only 50 square on that. Okay, here what is the trick here? If you know 50 square value, your number, any number, 50 plus something format, 50 minus something whole square format is there. So to calculate the rightmost part value, that extra value, surplus or deficiency value square, we have to write in the rightmost part. It must contain two digits on, right? And leftmost part, so 25 plus your deficiency, so 25 plus your surplus value, we can do it, right? So that is the thing. Okay, we'll see that with help of example we can get the clarity. So then we can go for actual understanding, right? So trick means what? Generally almost like a blind thing on, right? We have to understand actual facts also. So before going for that particular thing, so first of all I'm going for trick on, right? So if you know 50 square equal to how much here? It is a, so 2500 on, right? So 2500 on. It contains two parts. Rightmost part contains two zeros and leftmost part contains 25 on, right? Suppose if I want to find 51 square, 51 is not nothing but what, no? 50 plus 1 on that. One more is there, no? So to get leftmost part of your number to the 25, we can add that surplus value. Plus 1 we can increase it. So 25 plus 1 will get a 26 on. So to get what was rightmost part of your square, what is the requirement here? So to the 0 we can add square of that surplus value plus 1 square, we can write it. Its value 0 plus 1, 1 only, but we have to represent like a two digit number on, right? We have to write 2601, right? So let's consider 49 square also. Suppose if you know 50 square, already we know 50 square value, its value 2500 on, right? So I need 49 only. 49 is what, no? 1 less than 50. So 1 less than 50 minus 1. Na? To get leftmost part of your square, 49 square, just simply subtract what, no? 1 from 25. Right? So 25 minus 1 will get a 24. To get rightmost part of your answer here, just simply for to the 0 add that deficiency square value, right? So minus 1 whole square we can add to 0 we'll get a 1 only, but we need to represent it as a two digit number since base has a 50 here. So because that reason, right, we'll get 0 1 on, right? Next similarly, so I'm taking 44 square value. So 44 square value how much ma? When compared to 50, your number is what here? 6 less on, right? 6 less here. Okay, here also here to get leftmost part of 44 square value. So from 25, we can subtract that 6 value. 25 minus 6 value will get 19 here. And to the rightmost part value, add the deficiency square value, right? So square of the deficiency value will add it. What will get my here? 0 plus 6 square value, right? 0 plus 6 square value. So what will get? If we can get 36 on, we'll get 44 square value how much? So 1936 on. In that way, we can calculate it very easily. Now I'm taking 56 square I want, right? So when compared to 50, your number is what must 6 more on, right? 6 more. So to get leftmost part of your 56 square, so add 6 to the 25 on that. Add 6 to the 25, we'll get 31 here. And to get rightmost part also, add square of that surplus value, square of that extra value. 6 square we can add for 0, we'll get a 36 on, 36 on. Therefore, 56 square value, how much we got my here? We got 3136 on that. Okay, here with a blind trick, but even those 25 to 75 square values, we can write very comfortably if you know only just 50 square value on that. Okay, here by using this particular logic. With practice, we can do many squares very easily. Na? Now, I'm taking here 38 square value I want. Right? So, based on here also, based on 50 square value only I'm calculating, right? So, then see that here also same thing, 38 value, how much less than 50, right? So, we'll get it that 12 less, na? 12 less on. So to get leftmost part of your result, what is the requirement? from the number subtract the deficiency value. So 25 minus 12 will get 13, and square this deficiency value will add to the right hand part, right? Minus 12 whole square we can add it. Its value 144, but 1 is the carry na here. What will get my here if you simplify it like this? So by adding normally, so here I can get starting. So 13 will get in the left hand side starting. 13 will get, and 144 in the right hand side. So we need to add carry value. What we'll get? We'll get 1444 on that. Okay, to get clarity on this part, I'll give one more example. Just see that, right? See that? So now I want to calculate. So let's take 32 square value, right? 32 square value. Now we'll check it here, right? So 32 is how much less than your number base value 50. So 18 less on that. 18 less only. So to get leftmost part of your answer, we need to subtract 18 from 25, right? So we'll get this particular part. So to get rightmost part of your number, we have to square that deficiency value. We have to add to 0, 0 on that. 18 square on. What we left in here, we'll check it once. 18 square equal to how much? 324. We know that 324 on 24 will write, and 3 is the carry since base is at 50 only. Clear? Next one. So 25 minus 18 value, how much we'll get here by subtracting 18 value? So we'll get 7, we can get it, right? 7. But this carry we have to forward it now. We need to add this carry to this number. What will get finally? So 7 plus this 3 value will get a 10 on, right? 1024 we can get it, right? So if you know 1 to 25 squares, we can calculate the squares of many numbers with easily, right? Clear? So I'm giving one more example, and just see this example also. I want a 61 square on, and slowly every time no need to write 50. We can calculate it orally, na? Starting with to feel little bit comfortable, I'm taking every time 50. That's it, right? And here also same thing. So I want a 61 square value on that. So 61 square I want, 61 square on. Now we'll come when compared to 50, your 61 is how much more? 11 more on that. So what is the requirement here? So we need to get leftmost part of your result, 61 square value, add that surplus value to your 25 on that. So add 11 to 25. So 25 plus 11. So I'll get 36 on that. So to the rightmost part value, add square of that surplus value, right? 11 square we can add it. We'll get 121, but 21 we have to write it here. 1 is a carry on, right? So if you add this carry to this left part, what will get here? We'll get a 3721. Therefore, 61 square value what we got here? So 3721 on. Like this, we can calculate the squares of numbers very comfortably, right? So you can take numbers like this, you can calculate the squares of the numbers very normally, right? But what are the prerequisites here to calculate bit comfortably? So what are the prerequisite here? We should know squares of the numbers from 1 to 25, right? So prerequisites. So prerequisites to calculate the squares of the numbers from 1 to 21 to 125. So learn squares from 1 to 25, right? First of all, we have to learn squares from so 1 to 25. We should memorize it. Then only we'll get a more benefit, right? Without memorizing also we can calculate the squares of the numbers. But if you memorize it, you can feel bit comfortably, right? Many places. Right? So we know that numbers are very closer to standard base, right? So we know how to calculate the squares of the numbers. The technique we can use it. Standard base is there. What is the standard base value? So 10 power of any number where n is the whole number, we can consider like a standard base on that. Okay, suppose I want to calculate 9 square. Already we learned this technique before in previous lectures. So 9 is how much less than your standard base, right? 10 we can take it, right? 1 less only, we can write 1 here, right? 1 here we'll write it. Okay, now what is the rightmost part of your number in all methods case? Square that deficiency, square that surplus value, put in the rightmost part. Minus 1 whole square, will write it directly, right? But how many digits are there in the, how many zeros are there in the base? As many digits only we have to represent in the rightmost part of the number. That we know that to get leftmost part of this particular number, from the number you can subtract that deficiency value, or you can add the deficiency if you consider negative sign, right? 9 plus minus 1 will get 8 only. So 9 square equal to how much will get? Will get clearly 81, we can get it. So like this we can get it here. And similarly 12 square also same thing. So base is what ma here 10 on that. Like this we can use the calculation method, but instead of this particular thing we should learn, so till what ma, so 25 on. Now here also see that your 12 is how much more than your base value, we'll check it once. So 2 more on, right? So square the surplus value, extra value is there, it is surplus. Square it and put it in the right hand side of your number, right? Right hand side, rightmost part. Its value 4 only. We have to write only one digit on that. Your base contains only 10. We have to fill maximum what ma? One digit only we can fill in the rightmost part. Now to get leftmost part of the number, so to the number we can add that surplus value. 12 plus 2 will get 14 only. So 12 square equal to how much ma? 144 will get it. Like this we can calculate it normally. And similarly I want here 18 square value, right? 18 value how much? I'm taking standard base, converted base also we know that, right? Already we calculated. So standard base equal to how much ma? Here 10 only I'm taking. Your number is what ma? 8. How much more than your base value? 8 more. And square the this surplus value and put it in the rightmost part on that. 8 square equal to how much? 64 will get. 4 will write. 6 is the carry on that. So now to get leftmost part of the number, to the number we can add that surplus value. No? 18 plus 8 value will get what ma here? Will get 26 on. 26 plus 6 value here, what will get? 26 plus 6 value will get 32, will get it. So its value how much? Finally 324 we are getting. Otherwise you can take like a what ma? You can take like a convenient base only, converted base also. So 18 square we want, right? What we can do now, take your base value what ma, here 20 we can consider like that, right? 20 is nothing but what ma, 10 into 2 on, right? 10 into 2 only. So now when compared to 20, your 18 is how much less now? 2 less on. We can represent symbolically minus 2 on, right? Square this particular number and put it in the rightmost part on. Square the deficiency value. So 2 square 4, will write only one digit. Why? Base contains only 10 na, in it. So how many zeros are there in the base? As many digits only we have to take it. But when compared to standard base is a 10 na? So it contains 10. So we'll see that, right? Now to get leftmost part of this number, from the number we can subtract or we can add its a deficiency value. Why? Sign also we have taken here. 18 minus 2 will get 16, but here base is what? Standard base is multiplied by 2. Leftmost part also you have to multiply by 2, right? This 16 is what? 16 20 is not 16 10s, right? When it is 16 10s is there 16 on that. 160 will get it, right? So last what ma? So tens place, previous place value 16 on it will not get changed. But base is now 20 is na, 16 20 it is, right? 16 2 ja how much ma? 32. Its value how much? 3 2 will get 4 as it is on that. This is a technique on that. By using this technique we can find simple squares also. But what is the basic thing here? So we should know this method also, right? Base method. Now I can say the previous one also. So previously we calculated 49 square, right? 49 square. How we can calculate? There are two methods are there. I'm taking base as a 50 here. Previously I told blind method. Now I'm going for actual method. This base I can create in two ways on, right? So 10 into 5 I can make it. Your standard base are 10. I'm multiplying by 5, right? So otherwise I'm writing 100 into half will write it. Your standard base is 100. I'm multiplying by half on, right? So we'll see in both the ways, right? Starting, right? Suppose here your number is how much less than your what my deficiency. So you how much less than your standard base? 1 less on that. 1 less. Now square this deficiency value, put it in the rightmost part. Minus 1 whole square will get 1 only. If I take my standard base as a 10, in that case its value is 1 only. It contains 1 0, one digit only allowed in the rightmost part, right? Now here what we need to do to get leftmost part of the number. So to the number we can add its a deficiency. 49 plus minus 1 will get 48. This 48 is what? 48 50s, right? Remember 48 50s or 48 into 5 will write it. Why? Unit place already I wrote 1, right? So 48 into 5, right? Leftmost part only we need to multiply with the 5. Your standard base, how many times you multiplied with that number, you have to multiply leftmost part, right? In all normal multiplication case also, what you will get? 1. So 48 5 is equal to how much here? Into 10 by 2 will write it, right? 480 by 2, 240 will get. 2401 we can get. It is one technique, right? So when if I consider base value as this one, right? So if I take one more way, I can also we can see that 49 square is there. Now your number is how much less than your standard base? 1 less 1. Mathematically I am representing with what? 1 only. Now my base is 50 only here. My base is the 50. This 50 I created by taking my standard base as 100 into 1 by 2. Okay? Now see that. Now square the deficiency and put it in the rightmost part. 1 square is 1, but we need to write 0 1 here. Since my standard base is 100 here, two zeros are there in standard base. Two digits are allowed in the rightmost part. Right? Now we'll see that to get leftmost part of the number, to the number we can add that deficiency value. 49 plus minus 1 will get 48. So 48 into what here? Half we have to multiply, right? 48 into half on. What we'll get? We'll get 2401. So in this way also we can calculate it, right? So this is a way actually to learn the squares from 1 to 125, right? So when numbers are very closer to standard base value, it is very easy, right? When convenient base are there, right? Converted base are there, how we can handle leftmost part. That is the important.